Okay, this video is our first day of in-practice class for antiderivatives. And I gave you a homework assignment of the odds. So I'm going to do 2 through 22 even and number 29. I don't know how many I'm going to fit in the first video. I can kind of tell when they get kind of long. So we'll start with this first one. The first thing I want you to recognize is I have a little f of x here. If they show a little f of x, that's really, if you will, f prime of x. So that's your first derivative. And so they want you to find capital F of x, okay? And capital F of x is going to be your original function, if you will. Before we get started, this is what I did in class. We actually went through and did an antiderivative card. There's 13 derivatives that I want you, antiderivatives that I want you to memorize. So we're going to start out with like the power rule. And the power rule here is that if you're doing the antiderivative of a power function, I should say that better, you're going to add 1 to the power and then multiply by the reciprocal. So you're going to say n plus 1, and then you're going to flip it and multiply whatever your coefficient is by 1 over n plus 1. So whatever this number is, you're going to flip it. And remember, n can't be -1. If you do get a 0, that's going to be natural log. So let's go through this, and we're going to start out with some power functions first. So this first one, it's all set up nice and neat for power functions. So what I'm going to do the derivative, I'm going to add 1. So this is going to be x to the 10th. And when I multiply 1/10, because I multiply the reciprocal times 8, I'm going to get, it reduces down to 4/5 x to the 10th. And if you don't believe me, do the derivative, do 10 times 4/5, and you will come up with 8x to the 9th. So you can always check it as you go along. All right, so I'm going to add 1, so that's going to be x to the 7th, multiply by the reciprocal, so that's going to be -3/7. And then I'm going to add 1 to x to the cubed, so that's going to be x to the 4th, multiply by the reciprocal. You're going to get 3x to the 4th. And don't forget, you always have to put your constant c, because you could have a constant in your original function that if you took the derivative wouldn't even show, because a constant, the derivative is 0. So that's how you would do number 2, right? Number 4 is a function x times 2 minus x squared, and it's a product. So the first thing you have to do is, I'm not teaching you anything to do with a product with antiderivatives. So if you do get a product like this, I want you to actually multiply it out. So when I do, I get x times, and 2 minus x squared is 4 minus 4x plus x squared. And then I multiply them all by x. So f of x would be 4x minus 4x squared plus x cubed. You got to get it in that manner first before we can start doing the antiderivative. So now we're going to do capital F of x, which is our original function. We're going to do the power rule. So you're going to add 1, make that 2, multiply 4 by 1/2, so that's 2x squared. And then minus, add 1, that's going to be 3, multiply 4 by 1/3, so that's going to be 4/3 x cubed. And then we're going to add 1 to x to the 4th, multiply the front by the reciprocal, 1/4 x to the 4th, and don't forget your constant c. Okay, so that's 2 and 4. So you can stop this and try 6 and 8 and then watch what I do, or you can go through it with me if you want. So I have 6 and 8 here. So here's 6. I have little f of x is 2x plus 3x to the x, 1 plus 7. Okay, let's try that again. F of x equals 2x plus 3x to the 1.7. Sorry about that. So now we're going to do, it's all set up so I can do the power rule, or the antiderivative of a power function. So when I do, I add 1, multiply by the reciprocal, that's going to be x squared, plus add 1, that's going to be x to the 2.7, multiply by the reciprocal, so it's going to be 3 over 2.7 x to the 2.7, and don't forget your constant c. Okay, let's try 8. 8 is f of x equals the 4th root of x cubed plus the cube root of x to the 4th. So the first thing I'm going to do is rewrite this. So I have fractional powers, so it's going to be x equals x to the 3/4 plus x to the 4/3. Now we're going to go back and do our antiderivative. So capital F of x. So I'm going to add 1. So if when you add 1, you can add like plus 4 over 4 if you want. So I'm going to have 7/4. All right, so this is going to be 4/7 x to the 7/4 plus add 1. So that's 3 over 3. So that's 7/3 plus 3/7 x to the 7/3 plus your constant c. So that's 8. All right. Next one I'm going to do is 10. So here's 10. I've got it set up here where it's a quotient, so I know I've got to do some work to it so that I can actually write it with all power functions. So I'm going to divide each one of these by x to the 6 so that I can set this up. And when I do that, I get little g of x to be 5x to the negative 6. So I'm just kind of bringing that up for that. And then I've got minus 4. And then I have 3 more x's on the bottom, so it's going to be x to the negative 3. It's really 4 over x cubed, and I can bring it up. And then I've got x to the 6 divided by itself is just a plus 2. All right, now we can go through and find my capital G of x, or my original function, if you will. Okay, so here we go. I'm going to actually add 1. So when I add 1 to this, it's negative 5. And then you're going to multiply that by negative 1/5. So it becomes a negative 1, or just negative x to the negative 5. All right. Here, I'm going to add 1, so it's going to be negative 2. When I multiply negative 4 times a negative 1/2, I get a positive 2x to the negative 2. And if you'll get used to when you have a constant, because that's really x to the 0. So if I add 1, but if you'll get used to this, that has to be a 2x. So that I take the derivative, it would be 2 plus your constant c. So if someone asked me in class, how do you do that? Think of that as x to the 0, add 1, multiply by the reciprocal, and that's how you would do that, okay? But you don't really need it there. You'll get used to being able to do without it. Let's try 12. Now we're getting into, so we've done a lot of power functions. Now we're going to get into exponential functions and trig functions. So when we look at our derivative card, so let's look at it here. When I look at it with base e, so e has, hold it, e to the kx right here. So there's a k here, and the k in this one's going to be a 1. So when I do the reciprocal, 1 over 1 is 1. So sometimes you don't have to worry about it if k is 1. And then I have secant squared. So I go up here, secant squared, I know is going to be tan x, tan kx, but the k in this one as well is a 1. So that kind of simplifies it a little bit. So let's go back and do our actual derivative. So when I do the capital F of x, because the k is a 1 there, and I'm going to multiply the 3 by 1 over 1, it still is a 3. So you're going to get here 3e to the x. And then I'm going to multiply 7 times whatever 1 over k is, and k is 1, so it's still 7. I know this is 7 tan x. And don't forget your constant c. And again, you can go through and do the derivative and make sure you did that right, but that's how you would do that. I think the last one I'm going to do on this one is number 14. And I'm going to start with number 16 on the next video. So here's 14, excuse me. When I go to do 14, I've got to rewrite it so that that radical is 2 times x to the half plus 6 cosine x. And anytime with cosine and sine, if you look at the derivative card, I have on the back of the derivative card, this is what we did in class, is I have your trig square. And we've done this before. So here's a trig square that we have learned already. But if you do the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, and the derivative of negative cosine is sine. If you go backwards, the red arrows are your anti-derivatives. So it helps you if you know the derivative of cosine sine, the derivative of sine is going to be negative cosine. So you're like going in the other direction. That's pretty cool. And that will help you. So in this problem, we're talking about cosine. So the antiderivative of cosine is going to be sine. So that kind of helps you. So I would write the trig square right on my, if I have to do a quiz on this. So the first thing I'm going to do is do capital F of x. Okay. And when I do this, capital F of x, trying to get rid of that here. Okay, so when I do capital F of x, I'm going to add 1, so that's going to make that, for 14, I'm actually going to add 1, so that's going to make that 3 halves, multiply by 2/3, so I have 4/3 x to the 3 halves, okay, plus 6, and the derivative, the antiderivative of cosine is, we already looked it up, is sine, so that's going to be 6 sine x plus your constant c. All right, so I'm going to start the next video starting at 16.